In this lesson, you will learn about some of the ways a non-graph data model can be represented as a graph. As mentioned in the last lesson, index-free adjacency is a huge differentiator between relational and graph databases. While relationships are stored at write time in a graph database, the joins made in a relational database are computed at read time. This means that as the number of records in a relational database increases, the slower the query becomes. The query time in a graph database will remain consistent to the size of the data that is actually touched during a query. Having relationships treated as first-class citizens also provides an advantage when starting out. Modeling relationships in a graph is more natural than creating pivot tables to represent many-to-many relationships. Let's look at the Northwind RDBMS data model. In this example, an order can contain one or more products, and a product can appear in one or more orders. In a relational database, the order details table is required to handle the many-to-many relationships. The more orders added, and subsequently the larger the order details table grows, the slower order queries will become. In a graph, we can simply model a contains relationship from the order node to each product node. The product node has a unit price property and uses the contains relationship, which has properties to represent the quantity and discount. NoSQL databases solve many of the problems, and they are great for write throughput. But there are problems with how data is queried. The two most common NoSQL databases represent key value stores and documents. The key value model is great and highly performant for lookups of huge amounts of simple or even complex values. Here is how a typical key value store is structured. However, when the values are themselves interconnected, you have a graph. Neo4j lets you traverse quickly among all the connected values and find insights in the relationships. The graph version shows how each key is related to a single value and how different values can be related to one another, like nodes connected to one another through relationships. The structured hierarchy of a document model accommodates a lot of schema-free data that can be easily represented as a tree. Although trees are a type of graph, a tree represents only one projection or perspective of your data. This is how a document store hierarchy is structured as pieces within larger components. If you refer to other documents or contained elements within that tree, you have a more expressive representation of the same data that you can easily navigate using a graph. A graph data model lets more than one natural representation emerge dynamically as needed. This graph version demonstrates how moving this data to a graph structure allows you to view the different levels and details of the tree in different combinations. This completes our look at some of the ways a non-graph data model can be represented as a graph.